Okay, so let's start our final chapter, which is on the specific part of the immune system. And actually, before I get to that, let me pull up non-specific immunity. So I'm going to want to show you a little bit from that. Okay, so before we get into the specifics of chapter 17, let's review chapter 16. So remember, chapter 16 was on innate immunity, or what we call non-specific immunity, which is basically defenses that everyone has to a certain extent, and that you are able to do when you are born. So these include all of the things that we went through in chapter 16, such as fever, inflammation, making interferon, the complement cascade, the different barriers, and then also natural killer cells. So when we talk about our specific immune system, you're going to hear me talking about humoral immunity and cell-mediated immunity. Okay, so first of all, let me refer back to chapter 16. Let me pull this up. And remember, we went through and we talked about the different types of white blood cells. And so you had the granulocytes, and then you had the agranulocytes, and these included the monocytes, which turned into macrophages, and that was part of the inflammatory response. And then I mentioned these guys, okay? So lymphocytes. So these are also a type of white blood cell. They don't have granules in them, so that's why we refer to them as agranulocytes. And the lymphocytes are the cells that I'm going to be talking about in your specific immune system. Okay, so now let me go back to here. Okay, so you're going to hear me talking a lot about T cells and B cells. So the long word for this are B lymphocytes and T lymphocytes. And those are those types of agranulocytes. I'm going to shorten that up and just call them B cells and T cells because it's, it's shorter and it's easier. So the B cells are involved what we refer to as the humoral response. And these are the types of cells that will end up producing antibodies. The other side of the response is called cell-mediated immunity, and these refer to T cells. Now, one important thing that I want you to know, okay, the T cells are basically the boss of the B cells. Okay, so the B cells are the ones that produce antibody, but they will not be starting producing those antibodies unless the T cell tells them to. So, for example, this is why HIV is such a destructive virus in terms of breaking down your immune system, because HIV specifically attacks T cells. And so if you remove the T cells, then the B cells don't know what to do and they don't produce antibody. And so you end up wiping out that part of the immune system as well. You wipe out not only cell-mediated immunity, but also humoral immunity simply by attacking the T cells. So first, let's go through a bunch of definitions of different types of immunity. Okay, so first of all, the broad term immunity means the ability of an organism to simply recognize and defend itself against infectious agents or pathogens. So microorganisms, which the body should be able to detect as being foreign or not belonging to our own cells. Okay, so that's what immunity is. And then we also talked about in the last chapter about innate immunity. And so these are the general defenses like getting a fever, inflammation, things like that. They're coded for in our genetics. And we can basically do them as soon as we're born. Okay, what we're going to talk about in this chapter is what we call adaptive immunity. And that means that over the course of your lifetime, when you start seeing new pathogens, your immune system is going to be able to adapt and then to be able to respond to those specific pathogens. Like we're crossing our fingers now and hoping that people are going to be able to recognize and start building immunity against COVID-19. You know, fingers crossed. We don't have all the data yet, but hopefully with time, that is what's going to happen. Okay, the other term I want to mention is susceptibility. And remember that every person is an individual, and we all have weaknesses in terms of our genetics, which then translate to our immune system. And so some people in certain categories are more susceptible, like we've mentioned, the elderly, you know, the really, really young, or people who have other conditions. You know, they become more susceptible, but it can also be simply due to your genetics. You know, you've probably met that person, and maybe you are that person that, you know, they seem to never get sick ever. And then you have the other friend that maybe picks up every single cold or flu virus that happens to, you know, be passing through the population. So we're really completely individual in terms of our susceptibility. And really what that means is that a very susceptible person needs less of an infectious dose of that pathogen to be able to actually cause infection and then disease. Okay, so now we're going to talk about just adaptive immunity. So adaptive means that, remember, it's changing over time. A new pathogen comes into your system, and then your immune system is going to be able to respond to it. So when we talk about adaptive immunity, there are two main categories, okay? And then we're going to divide those into two additional categories. So if your adaptive immunity is acquired naturally, what that means is that you encountered the pathogen, you actually got sick, and then you are the one that your cells went through and you made antibodies, and then that hopefully gives you, you know, long-lasting protection against that organism. So if it's natural, it means that, yep, you know, you had to be exposed to it. If it is artificial, and we're talking about your immune system actually adapting, what that means is that you're getting a vaccination. So you're getting not the entire organism usually, but a hunk of the organism, and it's kind of fooling your immune system into thinking that you're being infected with the organism, and your immune system responds the same way. It's going to make antibodies, but you don't actually have to get sick and get the disease. So ideally, it would be awesome if we could get a vaccination for every single pathogen. Is that reality? No. I mean, for example, rhinovirus, which gives us the common cold, you know, that's more of a nuisance disease. So there's no pharmaceutical company that's going to spend a lot of money on working on a rhinovirus vaccine, because it's kind of like, you know, big deal. You get a cold, you get over it. It's not fatal. They're going to concentrate on potentially fatal pathogens like COVID-19 and like, you know, polio and other, you know, deadly pathogens. Okay, so another way of saying what I just said on this previous slide, another term that we can add to that is active immunity, okay? And just assume that the adaptive part is in there. I'm just not going to keep saying it over and over again. Okay, so active immunity, if it's natural active immunity, what that means is you're exposed to the bacteria, the virus, whatever it is, you get sick, and then because of that, you will hopefully have antibodies that could potentially last you your entire lifetime. So your immune system is doing the work, okay? And unfortunately, you have to get sick for this to happen. So that's what we call natural active immunity, okay? Remember, active is when your immune system is actually doing the work. Artificial active is when you get a vaccine. Okay, because you're still getting a hunk of the pathogen, but hopefully you're not getting sick from it. You know, the vaccines are normally not intact organisms. There are some that are, and I'll talk about those a little later. But hopefully you don't get the disease, but you do, because your immune system is doing the work, you still get the long-lasting immunity. Okay, so any vaccine would fit into that. That's the difference between active natural and active artificial. Okay, so remember, active means that your immune system is doing the actual work. Okay, then we have the category of passive immunity. And what passive means, as opposed to active, it means that someone else's immune system actually did the work and produced the antibodies, and you are just receiving the antibodies from that person, usually in the form of an infusion. Okay, so passive natural, this is a very specific situation. This is only from mom to baby. So this is where mom has antibodies that can actually pass the placental barrier and make it into the baby to give them protection, or it could be breastfeeding from mom, and there are antibodies that are found in breast milk, and those can also pass to the baby. Okay, so passive natural, between mom and baby only, it's very specific. Passive artificial is when you're giving antibodies after someone has had a known exposure. And these don't last a very long time. What you're hoping in this situation is, okay, let's take the antibodies from this other person who survived this disease, and give them to a person who was exposed. And it's basically like hoping that those antibodies will get in there and serve as molecular sponges and just kind of sponge up, the virus or the toxin or whatever that person has been exposed to. So you're probably actually hearing about this in the news now, because it's hopeful that people who have been exposed to and then survived COVID-19 now have antibodies in their serum, and potentially those antibodies could be donated or taken from the patient who survived and then given in the form of an infusion to people who have been exposed and are more susceptible. And it's hopeful that those antibodies will just go in there and suck up all that COVID-19 and keep it from infecting the really sick patient further. So, hopefully that works. Once again, it's kind of too soon to know, but that would be a perfect example of passive artificial immunity. Okay, so someone else is doing the work, someone else made the antibodies, and they're being given to you because there was a known exposure. So this is a good slide to actually break these down. So acquired immunity just means immunity that's specific, that changes over your lifetime. Adaptive immunity is another term. And then we have natural active. That's when you get the disease and your immune system responds. Artificial active is when you get vaccinated, but your immune system also responds. Natural passive is between mom and baby, and artificial passive is someone else made the antibody, and now a patient is getting an infusion of those already made antibodies from someone else. So when we talk about active immunization, of course, we're talking about vaccines. So the definition of a vaccine is a substance which contains an antigen. Okay, and I'm gonna get to the definition of an antigen, I think, in the next slide. But it contains an antigen and to which your immune system will then respond. And the hope is two different things. First of all, because you're usually not getting an intact, living, quote, living organism, you're not going to get sick, you're not going to get the disease, but hopefully the endpoint will be the exact same. You're going to produce antibodies and then a type of cells called memory cells, which can last in your system for decades. And then maybe the second, third, fourth, fifth, sixth time you're exposed to that same antigen, those memory cells start kicking out a ton of antibody right away. And so they stop that infection before it's able to get a stronghold in you. So of course nothing's perfect, right? There are certain hazards of vaccination. One thing that vaccination does not cause is autism. Okay, that has been absolutely disproven. In fact, the person who made those claims has subsequently admitted that he basically made it up to sell a product that he was developing. Okay, so yeah, that's off the table. Vaccines do not cause autism. Now, can I tell you that there's no one ever has a bad reaction to a vaccine. No. I mean, certain people have certain susceptibilities to vaccine components. So is everything perfect? No. But a typical vaccine takes about 10 to 15 years to develop. And so it's, not something that's done haphazardly. Obviously, with COVID-19 or other diseases that are, really, really scary and are killing a lot of people right away, they're going to hurry that, that production along, and you kind of hope for the best. But ideally, vaccine production actually takes a really long time. And a lot of that time is spent doing research in lab animals to seeing how they react and whether they even produce antibodies. Okay, so that's a little bit about vaccine production. But of course, there are some side effects. Some people develop a mild fever. Also, you can have a little bit of pain at the injection site. One of the things they usually ask you when you're getting a vaccine is, are you allergic to egg protein? And specifically an egg protein called albumin. So I'll explain why that is a big component of vaccines in just a couple of slides. Obviously, the worst case scenario is, someone having a seizure or going into anaphylactic shock. Thankfully, those situations are extremely rare in terms of vaccine. But could you get a mild fever and kind of feel kind of rotten, for a day or two? Yeah, that can happen. There's also another type of vaccine that are called attenuated, okay? And you don't have to know that term for the quiz, but what those are when it doesn't work as well to use just a piece of the viral capsid or, for example, a piece of the bacterial cell wall. The only way that the vaccine works effectively is to actually take the entire bacteria or the entire virus and use that as the vaccine. And normally what they do is they make the virus or the bacteria weakened so that it's not fully alive or fully active. But there's always the chance when you inject someone with an entire intact organism that it could revert back to an active or living form and then cause the person to get the disease. Okay, so attenuated vaccines, which fit into this category, are not given to women who are pregnant or people who are very immunocompromised, simply because you have that concern that, what if this comes back and then it potentially gives them the disease, and that could be a really, really bad situation. So that's what an attenuated vaccine is. So passive immunization, remember, that is giving antibody that has already been formed in another person. So it's done if a person gets a known exposure to the toxin that can cause tetanus, botulism toxin, certain snake venoms, hepatitis B, varicella zoster, rabies. And it's normally the person gets an IV infusion containing those antibodies from another patient. So it only lasts a short time, normally about, I would say, up to 48 hours. But the purpose is, let's get those antibodies in there and see if they can suck up all of the infecting toxin or virus or bacteria and get that out of the person's system before it actually does start to embed itself and cause an infection. Okay, so remember, that's passive artificial or passive immunization. Okay, so I'm at the 19-minute mark. I'm going to stop here and we'll pick up here next time. Thank you.